Hello everyone, and welcome to the third demo video of the phase 2 of the Bahmni-SNOMED integration project. In this demo video, we will see how Bahmni uses CDSS through FHIR to trigger notification alerts for various medical interactions by using SNOMED CT's terminology. But before moving to the demo, let's understand what is CDSS. So CDSS is a system that enhances the decision making of the healthcare professionals. It is a system that takes into account patients' information and its clinical knowledge base to improve the healthcare for the patients. It helps clinicians to avoid preventable mistakes by uh, providing the correct medications for the appropriate diagnosis. The benefits that we can see for CDSS is like it can help prevent mistakes, right, to curb preventable mistakes, then boost clinicians' efficiency. With that, it also helps in improved patient care quality, and also it reduces cost by avoiding unnecessary medications and procedure orders. Now, before we move into the demo and see the features, let's understand how the CDSS is implemented in our Bahmni-SNOMED integration project in the form of a diagram. Here in this diagram, we can see that we have a dev and a QA instance which houses the Bahmni application as well as the CDSS server. This CDSS server is filled with CDSS rules that has been custom built for showcasing this functionality. On the other hand, we have the Snowstorm instance, which is housing the Snowstorm server from where we get the SNOMED terminology terms. Now, once that CDSS server is launched, the first thing that happens is that the CDSS server basically prefetches the descendants of all the CDSS rules that are there using FHIR technology. What I mean by this is, so let's say if a particular diagnosis is contraindicatory with a medication, then that particular diagnosis and its descendants also will be contraindicatory to that particular medication. Similarly, let's say if a medication is in the form of a tablet and its strength is different, that particular medication will contraindicate the same diagnosis whether it is taken in different form or different strength. So all this information are prefetched through Snowstorm server using FHIR, and it is kept in the CDSS rules. So once that is done, then let's say the user provides the conditions and the medications through the UI into the Bahmni application. The UI in turn, through FHIR, it processes the medication and the conditions that has been provided, and it passes on to the CDSS server, which are both draft and save, meaning if there are previous diagnosis and medications as well, and the ones which are provided by the user right now, all those medications and conditions are passed on to the CDS server through FHIR. Now, CDSS server, based on the rules that are present, evaluates the conditions and the medications, and if there are any alert responses, it sends back the alerts to the backend, which in turn is getting displayed in the UI, and the user is able to see these alerts. So as I mentioned, for simplistic purposes, the CDSS rules that are provided has been very limited, and it is for the Bahmni-SNOMED integration project and to showcase this functionality. Now, let's move on to the features that we have. So currently, we are showing three different severity of alerts if any interaction is triggered. So let's say it is a critical alert, a warning alert, or an information alert. Critical alert basically avoids the user to save information about that patient without providing any justification of dismissing or overriding the critical alert. And as we mentioned that there can be different types of interactions. So in our case, we have covered, let's say, the drug diagnosis interaction, where a drug can be contraindicatory to diagnosis, drug-drug interaction, where a drug might be contraindicatory to a drug, and drug high dosage. So when a drug is prescribed into multiple number of times against the prescribed daily dosage. So all these alerts or any of its combination can be triggered simultaneously based on the rules. For drug diagnosis alert, as I mentioned, that the hierarchical classification of SNOMED CT basically helps to identify all the descendants of the diagnosis and applies the CDSS rules to those as well. So in our example, let's say if asthma and propranolol are contraindicatory to each other, so all the descendants of asthma will be contraindicatory to the medication propranolol. To mitigate the alert, the clinicians can make the amendments to the medication or the dosages in the medication tab. Or the clinician can choose to override the alerts by dismissing them. However, for the critical alert messages, the proper justification is required. Now, let's move on to first demo, which is based on the drug diagnosis interaction. I come to the Bahmni application. Under clinical module, I select one of the patient and move to the consultation tab. Here, let's say the patient is diagnosed with asthma. Okay. And the clinician is prescribing propranolol to treat this diagnosis. So the user selects propranolol, provides other information, and click on the add button. Here we see that a critical alert message has been displayed that propranolol is contraindicatory with the patient's condition asthma. The color of this alert signifies its importance. So the red alert basically denotes it is a critical alert and it needs to be addressed immediately. The user can also click on this alert to know more about the alert or the details of the alert. So here we can see that it is written the use of propranolol is contraindicated when the patient is having asthma, right? If the clinician wants to know more about this, they can click on this icon where the user is taken to the further information for that particular contraindication, right? In this case, we can see here, since it is a critical alert, I will not be able to dismiss this alert. Or if I want to record or save this person's data, the system will not allow me. It will say that a critical alert needs to be addressed in the medication tab. So there are two ways to address the critical alert. Either we can remove the medication altogether, or we can provide a proper justification or the reason for dismissal. So here, from this drop down, we can, let's say, check one of the reasons, select it, and click on dismiss. Now, as soon as I click on dismiss, we can see here that the system has dismissed the alert and has given an icon to show what are the alerts that has been dismissed. So in this case, if I click on this button, I will be able to see that what is the alert that was dismissed. So here we can see that it was a critical alert that was dismissed, and this is the summary as well as the details of it. Similar information I will get in the diagnosis tab as well against the diagnosis. So in this way, the clinician would know that a particular drug diagnosis interaction which was having an alert was dismissed by them, right? So this is about the drug diagnosis interaction where we saw that a particular drug is contraindicating with the diagnosis. Now, if the user wants to save the information, they will be able to save it because the alert has been dismissed. Now the system successfully saves the information. Now let's take another example of drug diagnosis interaction. I'll start with the medications tab. So let's say the patient was already prescribed with a medication named acetazolamide. Right? And it is added. Now, moving to diagnosis. Now let's say the user is diagnosed with hypokalemia. So as soon as I select the diagnosis, I can see I get an alert message. This time, a warning alert message based on the color of the ribbon. So here we can see that acetazolamide is a contraindication with the patient condition hypokalemia. And it also suggests the user to go to the medications tab to take further action. Now, since it is a warning message, the user can straight away dismiss the alert in the medications tab without providing any justification. So now let's say if I click on this, move to medications, right? Here we see that there is a cross button, which signifies that I will be able to dismiss it without providing any reason for dismissal. Similarly, we can, click on the alert to expand it and see more details about it. Now here I click on the cross button, which basically dismisses the alert, and I get a very similar icon of the dismissed alert. And upon clicking, we'll get the same thing, that which alert was basically dismissed. In this case, a warning message was dismissed, so we get a dismissed warning message. So these two examples basically demonstrates the drug diagnosis interaction. Now, here are some of the drug diagnosis interaction rules that we currently have custom built for our CDSS rule. Now, let's move on to the next feature, which is the drug-drug interaction. In this interaction, basically, it gets triggered when two particular drugs are contraindicating with each other. Now, let's take an example of this itself. So, let's say I save all the information that we currently have. Right? Now, based on the rules that we have, acetazolamide has a contraindication with a drug named allopurinol. So let me select allopurinol as one of the drug. And click on the add button. Right here, you can see that the drug-drug interaction is triggered. where we are saying that the contraindication of drug-drug interaction, acetazolamide is contraindicating with allopurinol. Now, in this case, we can also see that acetazolamide was also having a contraindication with hypokalemia, right? Now, in this case, since we have an active alert, the alert messages or the list of alerts are expanded and is shown to the clinician. In this way, the clinician would know that what all alerts were there against this particular medication. So in this case, if we see for hypokalemia, it was already dismissed and it is shown in the form of a gray color and strike through message that yes, acetazolamide, which had a patient condition with hypokalemia, this alert is already dismissed. Now we have an active alert of acetazolamide contraindicating with allopurinol, which is a drug. Now, since it is a warning alert message, in this case as well, user will be able to dismiss this alert without providing any reason for dismissal. So as soon as I click in this cross button, it will dismiss the alert. The point to note is, it doesn't matter that if the alert message is dismissed from this point or through allopurinol, it basically will dismiss the alert from both of the medications, as these are the medications which are actually triggering this alert. So if I click across from here also, I'll get the same result. So let's say I want to dismiss the alert from here. Right now we can see we also get the same icon for allopurinol also. So for allopurinol, it says that it has a dismissed warning of acetazolamide and allopurinol as a tablet, right? However, if we come in acetazolamide, here we will have two dismissed warnings, right? One with respect to hypokalemia, which was dismissed earlier, and the second one is for the allopurinol. So here, whatever alerts are dismissed against a particular drug, all those information are shown in this from this icon. And basically this icon denotes all the dismissed alerts that we have. This icon will not appear against a drug as long as there is an active alert. Let's take one more example. So let's say acetazolamide also has a contraindication with albendazole. Okay, so I select albendazole, provide the units, and add it. Now here we can see that acetazolamide is again having a contraindication with albendazole. Here we can see it also displays the previously dismissed alerts as well, which is of hypokalemia as well as allopurinol, right? And since there is one active alert now against acetazolamide, the dismissed icon is no more seen unless this particular alert is dismissed, right? Now we can dismiss the alert from any point, right? So let's say we dismiss the alert from here. Now, if we check on the list of dismissed alerts against acetazolamide, we will be able to see three. One for hypokalemia, one for albendazole, and one for allopurinol. So in this way, when a drug interaction is contraindicatory to each other, the system can trigger the notification alert. For the drug-drug interaction, also we have certain rules that has been designed for this functionality. So here are the list of the medications which are contraindicatory to each other, and basically it is shown in the UI as well. The card indicator basically indicates what type of alert message to be shown, and here we are also able to see the SNOMED codes of the medications. Now, moving on to high dosage alerts. In this alert, what happens? So let's say if a particular dosage is higher than the daily recommended dosage, then the system will throw an error or an alert notification. So let's see this by an example. Let me refresh this. Now, let's say the user is prescribed with medication aspirin. Okay. And it has been provided a dose of, let's say, 4 dosage frequency. So instead of, let's say, once a day or twice a day, the clinician by mistake chooses the frequency every hour and provides the duration and clicks on the add button. Here, as soon as we click on the add button, I can see that there is an alert message for high dosage. That it says that the amount of aspirin is 2.4 times the average daily dosage. So in this way, the user will be notified that there has been a high dosage alert for that particular medicine. Now, once the user expands this alert, they will be able to see more details of the alert. So let's say in this case, the substance in consideration is aspirin. Okay. And in which medication it is present, right? It was present in aspirin 75 mg oral tablet. The route of administration was oral, and the prescribed daily dosage was 7.2 grams. However, the recommended average daily dosage was just 3 grams. So in conclusion, it says that the prescribed amount is 2.4 times more than the average daily dosage. So in case of high dosage alerts, the system provides all the necessary information to the clinician to take the necessary action against the prescribed drug. Now, let's say if the user wants to dismiss, so since it is an information alert due to its color, here to dismiss the alert, the user will not need to provide any justification. So let's say the clinician or the user wants to override this and dismisses the alert. They can still go ahead and do the same. Right? Now, let's say in any other form, again, aspirin or the substance is provided. Right? Now, let's say in terms of 500 mg oral tablet again. Okay. Now, as soon as I click on the add button, since we are adding the same substance again, and it is already more than the daily prescribed dosage, so even the dismissed alert is again recalculated, and it is shown in the form of the new warning. If we see here, the dismissed alert is now again active, and it is showing that the amount of aspirin prescribed is 3.4 times the daily average dose. So it basically calculates, it takes into account all these all the drugs containing the substance aspirin, and then recalculates the average daily dosage or the it basically recalculates the prescribed dosage, not the average daily dosage. Now, in this case also, the user can go ahead and see the details. In this case, we can see that in which medications it is present. One is aspirin 75 mg oral tablet, and the other is aspirin 500 mg oral tablet. Okay, the route of administration was oral. Now, the prescribed daily dosage has moved to 10.2 grams, whereas the average daily dosage is still 3 grams. So now it has recalculated from 2.4. Now it is shown that it is now 3.4 times the average daily dosage. Now, the user can choose to, either, reduce the dosage, or let's say remove the medication altogether. So what happens in that case? So let's say the user decides to remove the medication 75 mg oral tablet. As soon as the user clicks on that, the system again recalculates the present substance, aspirin, and if it is less than the threshold, then it won't be showing the alert message. Now in this case, once I remove the 75 mg oral tablet, now it is below the threshold, hence we are not seeing any alert message. So in this case we are good to go. And let's say if I edit this information and try to increase the dosage for this as well, right, again the system will show me an error message. In this case, we can see that this time the prescribed time is 12 times the average daily dosage, right? So that is why it is shown as a warning instead of an information. So if the threshold passes beyond 4 times the average daily dosage, then the alert is notified in the form of a warning. Again, the same information we can see in the details as well, that the prescribed daily dosage has come to 36 grams, whereas the recommended daily dosage is 3 grams. Hence, the prescribed amount is 12 times over the average daily dosage. So in this case, we can see how clinicians can get the alert notifications if a particular drug is having high dosage of a substance. Now let's say if the user wants to edit the information, they can do it, or they can choose to dismiss the alert as well. Yeah, so this was all about the high dosage of the medications. Now there is one more feature with respect to order sets. So order set is basically our set of medications that can be provided to a patient for a particular diagnosis. So here we have seen all the various combinations, right? That the drug diagnosis, the drug information, as well as the high dosage alerts. Now, let's take a real life example with respect to an order set. So in order set, there are, let's say, more than one drugs which are combined in the form of a set to get to prescribe to a particular patient. Now, let's say for our example, there is a female patient whose age is 66 years, right? And she has a condition of fatty liver, right? And also in the medications, she has been prescribed earlier dabigatran capsule. Now she has visited the clinic as she is complaining of dizziness, high cholesterol. So through the observations, it was observed that the cholesterol level is high, the LDL level is more than 200. Hence, the clinician diagnoses her with hyperlipidemia. Right? So she is diagnosed with hyperlipidemia. Now, in order to treat hyperlipidemia, the clinician has a set of drugs in the form of an order set. The clinician searches for that order set. And here we can see that hyperlipidemia order set is there. The clinician clicks on the add button. Now, here, as soon as the clinician clicks on the add button, he is displayed with numerous alert messages. Now let's understand each of these alert messages. In our case, so the drug order set had two drugs, namely atorvastatin and aspirin. Atorvastatin was given to treat hyperlipidemia. However, the patient was already having fatty liver, right? And fatty liver and atorvastatin are contraindicatory. So in this case, we are able to see that there is a contraindication, that atorvastatin is contraindicatory with fatty liver. So we need to take some action. Also, we can see here that the second drug which is present in the order set is aspirin. And aspirin is actually contraindicatory with dabigatran, and which is a critical alert. So, contraindication of drug-drug interaction. So, a contraindication of drug-drug interaction is shown against dabigatran and aspirin. So, this is a critical alert message. Here also we are able to see, and against the aspirin also the critical alert message is displayed. Also, there is a high dosage alert for aspirin as well. It says that the amount of aspirin that has been prescribed is 2.4 times the average daily dosage. So basically, in the drug order itself, the custom aspirin dosage is shown, is prescribed as high, right? And if the user wants to click on the details, they will be able to see that the average daily dosage is 3 grams. However, the prescribed daily dosage has come to 7.2 grams. Now, in all these cases, the user can take certain actions. Now, let's say the user wants to, remove aspirin from the medication. They can do that by unchecking the button. So once they uncheck, we can see that aspirin is no longer prescribed to that person. As soon as that happens, all the alert messages are now removed because this aspirin is no longer prescribed to this patient. So the critical alert message as well as the high dosage alert message is also now gone. However, if I reselect aspirin, I can see that the CDSS again treats aspirin that has been prescribed to the patient, and it again shows the alert messages. And since we have a critical alert message, if the patient or if the user wants to save this information, they won't be able to do that. The system would say that we have to address the critical alert before saving the information. So what the user can do now, let's say they can take the reason for dismissal and they can go ahead and dismiss it. Once it is dismissed, we can see that it has been grayed out and stricken off, indicating that this is an dismissed alert. Since we are not able to see any gray icon against aspirin because we still have a high dosage active alert here. Now, if I dismiss this as well, we can see here that against aspirin, all the alerts that were there were dismissed, and now an information icon is there, which now shows all the alerts that were dismissed. So the dismissed critical alert, one with dabigatran and the high dosage information. So in this way, in real life scenarios as well, the user can take decisions based on the triggers or the alert notifications that are triggered through CDSS and make necessary adjustments. Now, Let's say now the user or the clinician is now satisfied with all the information that has been provided. They can go ahead and click on the save button. Now, since there were no critical alert message that were active, the patient's information is saved, and it is shown, all the dismissed alerts are shown in the form of an information icon, where the user need not take any other action here. It is just for their information. Yeah. Yes. So this was all about the CDSS feature in Bahmni-SNOMED integration project, where we have demonstrated how CDSS is used in Bahmni by using the SNOMED terms through FHIR, and based on the rules that are there, the notification alerts are triggered and displayed to the user. This was all for today's video. Thank you so much.